my section, I have 6.8, which is L'Hopital's rule, and we have to compute the limit as x approaches 0 of 5 over natural log of 1 plus x minus 5x. First I just rewrote it so that I wasn't dealing with two fractions anymore, and then I pulled out my constant, which was this 5 over here, so you get this, but when you plug in 0 for these x's, you get 0 over 0, which is how you know you have to do L'Hopital's. L'Hopital's is just taking the derivative of the top and the bottom, so that when you do eventually go in to plug that 0, you get something that isn't like this 0 over 0, so you get whatever your answer is going to be. So first you have to take the derivative of this top one, so this numerator section, and you get this. This 1 over u came from the chain rule over here, or like u substitution, not chain rule. So you get natural log of u, your u is 1 over x, so this is what you have there, and then you combine these two to give you this, and you plug back in your 1 over x for u. So that's where that came from. And then you come down here, derivative of 1 is 0, derivative of x is 1, this is still just your x, this was your derivative of your x, was what this 1 is, and then this stays the same, so you end up with this, which then simplifies down to this. So this is what the derivative of your numerator is. And then you come down to your denominator, and you have to do the product rule. So you have f of x times g prime plus f prime times g of x. And you get this. We already did before, so I just brought it down because it's the exact same thing. And then here, derivative of x is 1, and then you just have natural log of x. So then you take all of this, so this x plus 1 times natural log of 1 over x, and put that over 1 plus x, so you're left with this. So that's the denominator numerator. So eventually you take all that, combine it, get this. Still your 5 is out front, so you plug in 0, but when you do that you still get 0 over 0, so you have to do L'Hopital's again. Your first derivative is super duper easy because it's just an x, so the derivative of x is 1, so that's your numerator prime. But then when you try to do your second one, you have to do some like product rule and chain rule. So first you're just, it's just like the sum of the differences or whatever. Not the sum of the differences, but like, you take the derivative of this plus the derivative of this. So the derivative of this is really easy. It's just going to end up being 1. We already know that. But then this one, you have to go and do a product rule again. So you have f of x times g prime plus f prime times g. So then you come down here and you get this. This 1 came from this x prime, and for this you end up with this. It's kind of rewritten out, and then over here you end up with, I just moved the one up front here because I liked having it in the front better. I don't really know why I wrote it. Well, I do know, I forgot it, but then I just added it back in up the front. So then for this one, you have to take the derivative. You have to do another rule with that one. This one's easier because this just becomes 0. Right here comes 0. So you just end up with 1 times this function. So here you are doing a chain rule. So you have your ln u again, which is similar to what we did up here with this 1 over u. So you have that times this times g prime. So there's that. And then you get, like I said, this is just this derivative like we did up here. And then you put all of this, these two, over u here. And then because u is that 1 plus x, because it's, like I said, same thing as up there, I just wrote u equals 1 plus x. And then that cancels out with that. So then you are left with this. You're left with 1 plus derivative of 1 is 0, derivative of x is 1 plus this. So then you're left with 1 plus 1 plus natural log of 1 plus x, which gives you 2 natural log of 1 plus x. So that's all of that work there. I know that's kind of confusing to follow. So basically you have that. And then you end up with, over here, this is your final thing. Once you combine this and this right here. So that's what you're left with. Now you can plug in 0, so you get natural log of 1, which is 0, so then you get 1 over 2, so you get 1/2, and then you have to remember to multiply that by 5 because that's your constant, so you get 1/2 times 5, which is 5 over 2. So 5 over 2 is the answer to this initial problem. And for my second one, we have to prove if the limit as x approaches infinity of 3 over x to 5x is infinity. And for this, we're going to use the limit chain rule. So basically you have this u equals e to the natural log of u, and you rewrite this so that the natural log is now that exponent to that e, and then you rewrite it over here so that you take your 5x out and put it in the front, and then your 5 is a constant, so that can come out. Oh, this was just rewritten too. So then you take that 5, rewrite it again so that it comes out in front of that limit. So basically you just took this problem essentially and like put it up as the exponent to this e. And then this actually ends up approaching negative infinity. It just continues down forever. So because of that, it equals 0. And so therefore, the limit as x approaches infinity of 3 over x of 5x equals 0, which is not equal to infinity, which means it is